to give Jason a chance to talk. He's been kind of quiet so far. We're going to talk a little bit about what Bantam can do, that if you want to make it an easier transition, how you can enable companies to make this easier, particularly looking at the volumetric, starting to do the six-sided box that you've been talking about.
Yeah, great comments from everybody, so there wasn't really much to add. Really good stuff. It's all about designing for manufacturing. Our product's net zero ready, so we just don't know how to build any other way. It's part of our DNA. It's about air infiltration. It's about using the right windows. These guys are all talking the absolute right stuff. We just do it at a scale. We do it in a factory. This is how people right now are building factories trying to optimize an inefficient system or automate an inefficient system. I won't call out names, but there's plenty of factories that are building out of wood timber, right? And this is what they're investing in. And these are very capital intensive to put together, and to be honest, tons of moving parts, lots of parts and pieces, a thousand ways to screw it up, and you'll do it 2,000 ways. And, so this is just an example of automating inefficiency. You get the wood build, and you're going to insulate the wall. Even though it's an automated insulator, you still have another part piece. Now you're H-blocking your insulation in there. Now here's an example of optimizing efficiency. This is how we make our Bantam panel. Very automated. There's two guys that run this line. So this is, if you've never seen a SIP factory or how they make SIP, this is one example. This is the way we do it. It's very fast. We have a couple of different types of glues we utilize, hard and cold. So our panel press is about a 1 minute long panel press, and that panel is ready to go to the CNC to start cutting. It is a very low carbon solution. Our average 2,000 square foot home compared to a builder next to us, we have an 85% lower embedded carbon footprint in that envelope. So it'll set in that press for about a minute, and then it moves on. From there, we take it into automation, and then we turn it into boxes. So we actually take it beyond the wall panel solution on site. We've done over 3 million square feet of this type of construction in South America. We've built the Straits of Magellan Whale Observatory. We're the only one with a house in the South Pole. The Atacama Desert hasn't rained there in 300 years, 120 degrees heat. So we perform better in hot and cold environments, right? This is about energy envelopes. This is a particular volumetric piece going out in South America right now. We completely finished that unit. It is complete on the exterior. We use a super lead material. It has a cork inside that material, so it has a 10% retention memory. We don't crack, so we won't have cracks in the joints because of that 10% retention memory. I'm working with Bayer and 3M right now in Minneapolis on creating that solution here, so I don't have to buy it from outside the United States. So we have some great science groups in the U.S. to create some of this stuff. But it all starts with the envelope. This is a pod of a 5-star hotel that we did in Uruguay, and you can see everything inside of that is finished. And notice the glass. Notice how much glass we have on that end cap. Typical wood construction, you don't do that. It won't engineer. The structure's not there. Our panels are very strong. They are structural panels. We can go 3 stories without anything added to our structural envelope. We go above that, then we have to start adding some structural support.
And so give an example of what type of furnishings you're putting. I mean, obviously we can see a bed and a couch in there, but it goes even beyond that.
Well, yeah, I mean, they're 90% complete. The appliances, the carpeting, the flooring, the ceramic tiles, the shower door enclosures. When we're doing Marriott hotels or any other branded hotel, when you come in open the bedroom door, it's done. Everything is complete. There is nothing to do except in the corridors. So we take, the biggest fight we're going to have is trades and skilled trades. We bring them all inside of a factory. It's a teaching environment, and we do all the work there, and we deliver it out complete like that. It's just stitching that's done on site and some of the exterior cladding.
And we spent some time yesterday talking about resiliency, and there was a question this morning of, well, we don't want to use this because we're in Florida.
Yeah.
We've got some before and after pictures here of one of these houses that was before hurricane and after hurricane.
Yeah. Our chairman of the board actually had a house in Freeport, Bahamas when Hurricane Dorian went. And if you see there to the left, that is the before and after picture. All this client had to do when that water receded is pull their electrical wiring out of the walls that are in the cores, new breaker panel, base cabinets, and flooring. Our product doesn't mold, so there's no biologicals. We don't have to remediate for water.
How high was the water in this?
All the way to the almost very top of those windows for 2 weeks before the water went out.
Wow.
The houses to the right, the top, that's in Chile. Santiago, we went through an 8.2 magnitude earthquake in Chile. It was the largest recorded. No issues. Again, we have retention memory in our joints, so that's a nice product. And then the Atacama Desert over there to the right, that house has been there for a long time, and it never rains, 300 years. The one on the very bottom is the home we did in the South Pole. It's still there. So if you don't know, in other parts of the world, when you build a product, you actually have to build a home and let it set for 3 years, and they get to inspect it over a 3-year period before you get a license to build there. So we've been doing this about 8 years. We received investment from Breakthrough Energy Ventures, which is a fund put together by Bill and Melinda Gates to attack the carbon use in the world, and we're their only housing solution they invested in. We'll be putting 15 factories in the U.S. with builder-developer partners. That's our goal, is to reduce that carbon footprint in housing. We could have a whole other seminar on just what housing and construction does to our carbon footprint. We look at materials that will actually eat carbon and pull it, and we can use it in our home that'll pull the carbon dioxide out of the air into our envelope and actually reduce that as well. It's pretty technical, but there's some really neat stuff out there.
On the top right, fire resistance. Talk a little bit about that.
Yeah, we'll in SIPs, you have to, or any construction, you have to meet fire ratings, and so this is a test being done by NTA that is burning the wall, and our wall is. A lot of people ask me, is it MgO? Is it magnesium oxide? Is it an MgO board? It's not. It has a portion of that in there, but our group bought Burrell in Houston for the simple reason we needed coal ash for the next 200 years. It lowered our carbon footprint even further in our envelope by using a coal ash, which is a byproduct waste of coal. So we have coal ash in there. There's a lot of materials in what we make and how we make that. We didn't patent it because patents expire, and we just simply took the Coke method. So you can't get that ingredient. A lot of people try. We've had 9 years of practice at it, and it's ready to go. We are certified here in the United States with NTA right now. But it does have a refractory material. I use the analogy with people because I'm a visual guy, but when you imagine the space shuttle coming back in the U.S., everything on that thing is white except the nose. The nose has a black refractory material on it, which is what we use in our walls. And that's why that shuttle doesn't burn up into many pieces when it comes back in the atmosphere. You can burn and burn. The only thing that ever gives on that test is the actual EPS behind it. Our wall will not fail. It's the heat of the foam that will eventually disintegrate.